Welcome to Module 4, Lesson 12, the scale factor as a percent for a scale drawing. Another ugly title, but anyway, this Lesson 12 begins Topic C, whose subject is scale drawings. Okay, and this first lesson will attempt to take a look at scale factor, which we've looked at before, and convert that into a percent for a scale drawing. Okay? So as we move on here, yes, do you remember scale factor? Okay, scale factor. Remember, scale factor, also known as constant of proportionality. Okay, we saw this way back when in Module 1, and it was a bit of a struggle for some, not for all, but for some. It was took a little bit to get our minds around, and it may indeed be a challenge once again. But always good to see something a second time. And in this case, we will kind of change it up a little bit. We'll look at it in terms of percentages as well as ratios and fractions. Okay. Yeah, so we had ratios and fractions. That's how we looked at our constant of proportionality in the past, and now we will look at percentages. Okay. So let's go ahead and do this. Here, our classwork. This first exercise, this first activity, will bring back scale factor and show us how we'll use this as a percent for scale drawing. Okay. So here we go. we're going to compare the corresponding lengths of figure A to the original octagon in the middle. Okay, so that one octagon in the middle there is the original. Okay, that's where we started from. Okay, and then we went ahead and created, or not we, but they went ahead and created figure A right here. Okay, so this figure A is now a scale drawing. Okay, it's a particular type of scale drawing. All right, and this is what we're getting to here. We're going to fill this word right in that empty space there, and some of you may know what we call this particular type of scale drawing. Okay, it is called, of course, a reduction. Okay, it's a reduction. All right, and why is it called that? Okay, I'm going to go around the room here, and I'm going to choose the first person to raise their hand. Okay, yeah, you over there. Explain. Why is it called that? Yes, of course, it is called that because it is it's smaller. Okay, it is smaller than the original. Okay, as you can see, and has been reduced. Okay, therefore it is called a reduction. All right, that's a terminology we'll be using. So now we're going to go ahead and look at B, figure B. Okay, below it there. All right, here, figure B. Going to look at that figure, and we're going to compare it to the original, which is there in the middle. Okay, and this, of course, has a very particular name, and that special name is called an enlargement. Okay, an enlargement, probably a term that we're more familiar with than reduction. Okay, we often make enlargements of the photos we take, maybe. Yeah, the enlargement. And why? Because it has been enlarged. It's bigger. Okay, that's why it is called an enlargement. Okay. All right, so here at the bottom, the scale factor is the quotient of any length in the scale drawing to its corresponding length in the actual drawing. Okay, so as far as, now this first one here, this is the original. Okay, this octagon here in the middle, it's the original. It's the actual. Okay, it's also called the actual. All right, that's what it looked like. All right, the other two, this one here, which is the enlargement, and the reduction up top here, okay, these are what we know to be called the scale drawings. Only those two, only the red figures are the scale drawings because they are actual manipulations, if you want to say, of that original drawing. Okay, all right. So here it asks us to use what you recall from Module 1 to determine the scale factors between the original figure and figure A and the original figure and figure B. Okay, so now we're going to go ahead and we're going to compare these numbers, the different dimensions of these scale drawings, and compare them to the original, and we're going to come up with some scale factors. Okay, so let's go ahead and do that. Okay, scale factors between original and A. So let's start from there. Okay, we're looking now. We're interested in figure A. Okay, so we need a couple of dimensions here. So if we go ahead and look at the that one side length, okay, the side length right there, we see in the original it is 4. Okay, and in figure A, which is a scale drawing, it's 2. And you'll notice how those have been laid out in our fraction. Okay, you can see what sits on the bottom is 4 because 4 represents the original, and that is always the way this will work out. Okay, because we're comparing the scale drawing to the original. Okay, therefore that 4, the original, is always going to be on the bottom. And therefore you can see, and this makes sense because we've actually created here a fraction that is 2/4, okay, which is less than 1, okay, which is smaller than a whole, which makes sense because we've created a reduction. Okay, we've gone down in size. Therefore, it would make sense that our scale factor would be less than 1 or less than a whole. Now, if we go ahead and make of course 2/4 equals 1/2, which equals 50%. And that 50% is what we are looking for in terms of now expressing scale factor as a percentage. Okay, so figure A represents 50% of the original drawing. Okay? All right, so now if we go ahead and what did I write up there? Same relationship. Okay, same relationship. Alrighty. Now I'm going to go ahead and look at the scale factor between the original and B. Alright, and B. And as you can see, now that turns out to be 6/4. And again, I've just taken a couple of these. I've taken these measurements. Again, the side measurement. The measurement that was 4 in the original is now 6 in this scale drawing B, okay, in figure B. All right, and that's going to be 6/4, which makes sense because this is an enlargement. Okay, we've gone up in size. The size has gotten greater. It's 6/4, which is more than 1, which makes a lot of sense. And if we go ahead and just reduce that down to 3/2, and that, of course, as a percentage, is 150%. And that makes sense because that figure B would have a scale factor of greater than 100% because it is larger. It has been enlarged. Okay, so its scale factor as a percent is 150%. Okay, so here we go. We are going to just continue with this figure. All right, right here, and what they want us to do here now is using the diagram. Okay, complete the chart to determine the horizontal and vertical scale factors. Okay, yeah, and you'll see most of the time when you get a scale factor, it will pertain, or it will be applied to both horizontal and vertical measurements. Okay, if you say the scale factor is 150%, generally that is going to mean that it is that 150% is applied in all directions. Okay, but sometimes they do indeed apply a horizontal scale factor, which is actually different than a vertical scale factor. Okay, but let's go ahead and see what the case is here. Okay. Okay, and that's again, yeah, it just can be different. All right. But here we go. Let's look at figure A. So we're taking figure A, and we know that figure A, the horizontal measurement in the scale drawing is 1 to 2. Okay, horizontal is 1 to 2, which is 50%. Okay, and the way we see that is horizontally we have 1.5 up there, our horizontal line, and in the original we have 3, which is 1.5 over 3, which is the same as 1 over 2, excuse me, which is 50%. Okay. All right, in figure B, we have 3 over 2, which equals 150%. Okay, this is horizontal, and again, the way we see that is we have 4.5 for figure B over 3, which is the same as 3 over 2. Okay, which is 150%. Okay, and looking vertically, we actually this is the measurement we actually took the first time around. We of course can see that in figure A we have 2 over 4. Okay, and we're comparing to the original, and in figure B we have of course 6 over 4, which is the same as 3 over 2, which is 150%. So as you can see, we're going to make a concluding statement. Figure A is a reduction of the original figure. Okay, B is an enlargement of the original. And furthermore, we also notice is that the horizontal scale factor on figure A is 50%, as well as the vertical measurement in scale drawing is 50% as well. Figure B is 150% horizontally and 150% vertically. Therefore, it does have just one basic scale factor. Okay, 150% of the original and 50% of the original. Okay. All right. So here we go. I hope you're tracking along here, moving smoothly through this. This lesson may take a little bit longer than I wanted to, but again, this is information that tends to be a little bit confusing for you guys. So bear with me. All right. So right here we are going to create a snowman on the accompanying grid. All right. So what we need to do is we're going to create a head and then a bottom section. Okay. Now we are going to use the octagon given as the middle of the snowman with the following conditions. Okay, so there's the middle right there. We need to calculate the width, neck, and height for the figure at the right. Okay, so the width is this measurement right in the middle. Okay, it's going to be our farthest reaching horizontal measurement. Okay, which is shown by that line and those arrows there in the middle. Okay, so we need to calculate that first, and we're going to use our boxes here to help us out. Okay, and then that is our neck. Okay, the neck right there you can see, and again we're talking about this this octagon here, which has some names to its points. I actually never heard of that term neck, but yeah, there it is. That's the neck. And then, of course, the height is the easy one, and that's the height right there. And again, you want to take that height measurement from the middle, okay, which just makes sense. Okay, we're talking about height. We're talking about something like an octagon. Okay. All right. So let's go ahead and calculate those figures. So the width is 20 units. That's pretty messy looking, too, right there. Let's go ahead and fix that up. 20 units, okay. So our width is 20 units. Again, that's that line across the middle, okay. The neck is 12 units, all right. And the height is 12 units, okay. So we have a width of 20, and the neck is 12, and the height is 12. Okay, so we're going to use those measurements and we're going to apply a scale factor, which they're about to give us here. You can see it coming up in B. And we are going to create the head first. Okay, we're going to create the head. All right? So I'm erasing all that. Now to create the head of the snowman, make a scale drawing of the middle of the snowman with a scale factor of 75%. Okay, 75%. And calculate the new lengths for the width, neck, and height. Now, I hadn't thought about this before, but just thinking about it now, here we go. We have a perfect application of our Q equals P times W. Okay, right? This is perfect, because what we have here is we're trying to figure out the Q, trying to figure out the new quantity, okay, or the new the new length, width, and neck. All right, and we're going to apply a percentage. In this case, that percentage is going to be the scale factor times the whole, or the original, which is that middle octagon. Okay, so yeah, we are applying our handy-dandy Q equals P times W. And if you do that, life becomes so much easier. So let's go ahead and do just that. Okay, so for the width, our new width is going to be, okay, width as being our new quantity, is 20, which is the original, times the scale factor, which is 0.75, and that's going to give us a new a new scaled down. As we can tell, it's scaled down because it's reduced, because it's 75%, which is of course less than 100%. 15. So we have one that's going to be 15 units long. Our neck, now if we apply that scale factor, is going to be 12 times 0.75, and that's going to be 9 units. Okay, 9 units long for the neck. And then the height is going to be 12 times 0.75 as well, and that will be 9. So now we have our scaled down, our 75% scale drawing of which we're going to use for the snowman's head. Okay, so we can go ahead and actually we're supposed to just do all the calculations and then put the snowman together, but the way I did it, I actually put the snowman together as I went along. So here we go. Here's my attempt to put the snowman together. I started with the height. I just wanted to get that out of the way, and I tried to put it as close to the center, well, actually at the center if I could, okay, because this neck, the original neck here, is 12 units, so I put it right at 6, 6, right between 6 units right there, which made sense, 6 on each side, so I put that right in the middle, okay, and then I went ahead, and from there I went and took care of the neck size, okay, and it's a little not perfect, I mean, it's not going to be perfect looking, because actually 9, the way you split that into 2 pieces was, 4.5 on this side and 4.5 on this side. Okay, so yeah, there we go. So I did that, and then I went ahead, and what I did is I went from the middle and I made my, let me go back one. Let me see, stop right there. See, so I made my dots, and those dots, what those dots stood for, okay, were my my width, which was going to be 15, which is going to be 7.5 on each side, so 7.5 length on each side, okay, all right, and then I knew down here that this little piece right here, which we didn't actually talk about, this little piece was actually, let's see, 1, 2, 3, 4 units long. Therefore, the one up top here, my new one here, had to be 2 units. Okay, 2 units long there. So I was actually comparing these two as well. Okay, so I'll get rid of all that. It's a little bit confusing. Okay, but that's how I came up with these 2 dots over here and over here. All right, just to show you how I did it, and you may find a better way to do it. Believe me. Okay, so then I created that part, and then of course just attaching the other part same exact way. Okay, and again, just after I'm done, I'm just looking it over. I'm just making sure that I have my width right here is going to be 15, okay, and my height is going to be 9, and my neck right here is going to be 9 as well, and that all checks out. So that's what my head of my snowman looks like. Okay. Alright, so now to create the bottom of the snowman, we're going to make a scale drawing of the middle of the snowman. Again, we're using that middle snowman part as our original or our actual. Okay, and we're going to have a scale factor now of 125%. Okay, so we're going to go ahead and calculate the new lengths for the width, neck, and height. And again, we're just applying now, or again, we're applying the scale factor of 1.25, which is we find here. Okay, so 20 times 1.25 is 25. So we're going to have it 25 units wide. The neck is going to be 15 units now. Okay, applying that same 1.25 scale factor, and the height is going to be 15 units high. Again, applying the 1.25 scale factor. And as you can see, these numbers here, the original numbers, are the same for when I calculated the head and when I calculated the bottom. The neck, the same. Okay, so I'm always using these numbers as my basis. Okay, that's that original, the original snowman part, which was the middle. Okay. All right, so here I am. Just now, I did this a little bit differently. Okay, I went ahead and used my my width. Actually, I used the neck this time. I started with the neck, which was 15. So I just did that 15 across right there. Okay, and I know that 15 is, again, 7.5 on each side of the middle. Okay, and I just matched those two up right there. So I did a little bit differently. You'll get better at this. I'll get better at this, okay, as we try to make these as precise as possible. All right. I made those two lines. So now I have my neck lines, okay. And next, I decided to make those two dots as I did before, okay, right here and here. Again, comparing this length and then applying 1.25 to it, because that was 4. So 1.25 was going to make this 5. So this had to be 5 units long, okay. And then I just split the difference there, the 5 units, finding my middle part, okay. Again, and there we go. And again, that all this part here, honestly, all this calculating part right here to get 25, 15, and 15 is the easy part, because we've had so much practice applying percentages to original numbers. In this case, they're not only percentages now, we're calling them scale factors. But making the drawing is a little bit, it's more complicated, because it's an octagon too. It's a little bit, but you'll get better, and then, like I said, so will I. Okay. Now, these are a couple pretty simple questions, and maybe a more challenging one to boot. But yeah, D asks us here, is the head a reduction or enlargement of the middle? Pretty obvious, okay? Of course, the lengths are smaller, and the scale factor is less than 100%. Therefore, of course, that head is a reduction, okay? Is a reduction, all right? And, yeah, is the bottom a reduction or enlargement of the middle? Again, pretty obvious as an enlargement, because the lengths are larger and the scale factor is greater than 100%. And again, in both of these cases, when we created the head and when we created the bottom, we used one scale factor only. Okay, so we applied that scale factor, the same scale factor, to both the horizontal measurements and the vertical measurements. Okay, like I said, which isn't always the case, and which is what we'll practice that in a minute. Okay. Now, F asks, what is the significance of the scale factor as it relates to 100%? And I didn't highlight this, but what happens when such scale factors are applied? Okay, well, a scale factor of 100% here creates a congruent drawing, the same scale. So if I were to create a piece of the snowman that was 100% of that middle section, it would be the same exact size, and therefore it would be what we call congruent. Okay, it'll have the same measurements. Okay, same measurements all around. Okay, same scale. Now, scale factors less than 100% yields a reduction, all right? And scale factors, of course, greater than 100% yields an enlargement, okay? So 100% scale factor is congruent. Scale factors less than 100% are reductions, okay? And then scale factors greater than 100% are enlargements, okay? So should be pretty clear, and hopefully it becomes clearer and clearer, okay? All right, well, G, use the dimensions you calculated in parts B and C to draw the complete snowman, and of course, we have done that already. Okay, here's a kind of a simple one, and maybe somewhat, it might be somewhat challenging, but I'm going to have you go ahead and pause. Pause after I explain what we're doing here, or you can see what we're doing. Create a scale drawing of the arrow below using the scale factor of 150%. Okay, so I'm going to go ahead and pause. I want you to struggle with this yourself, or yourselves, and come on back, and we can check it together. Okay, well, let's see how you did. Okay. So first of all, we can see that it's an enlargement, okay, because we're going 150%. So if we don't create an arrow that is larger than this original one here, then we know something has gone wrong, okay? And the first important thing to do, of course, first of all, and not only important but necessary, is to actually take our measurements of our original, okay, and I've done that here. 2 by 12, it's a 2 by 12, pretty much 2 by 12 rectangle. Now the one important measurement you might not have thought to take, I'm not really sure, is this one right here, that 4, and I thought that this was a very important measurement to have, okay, right there. And of course one more measurement, which would have been that one right there, okay, that kind of the length of the beak, or the length of the point of the arrow, okay, which was 4 as well, okay. And you can see this is pretty much a 4 by 4 here. It's kind of a square right there that's actually been, cut to, 2 pieces of a triangle have been cut out there, okay. Yeah, kind of maybe a decomposing, or a composing and then decomposing. All right, so when I went ahead and did that, so then I have to go ahead and apply my scale factor, which is 150%. Therefore, my measurement of 2 is going to turn into a measurement of 3 units. My measurement of 12 is going to turn into 18. And my measurement of 4, okay, is going to turn into 6. And that's all I need, because those are the three numbers that I have. I have my 2 here, 12s, and a couple of 4s there, okay? All right, so there we go. And then all I have to do now is that's just time to draw, okay? One of my favorite things to do. All right, so I am going to make a, actually I think I trimmed that a little bit there, but that's supposed to be 3 units. Oh, there we go, okay? And then I have 3 units there, and then lengthwise they are now 18, okay? So I have those done. Here we have 3 and 18, 18 of course, okay, and now I know that the length of the bottom of that arrow, or bottom of the head of that arrow, has to be 6 units. Therefore, I see that I have already 3 inside of here. Okay, this is 3 right here. We put it in red. This is 3. Therefore, I need 3 more. So each of these is going to be 1.5. You can see right there. Okay, so this total thing is going to be 6. Okay, so I made a big mess there. Anyway, but that is 6. If you add that up, it's 6. Okay, and then all I need now to do is to I drew a line here just to make sure. I drew a line that was 6 units, because that my 4, all 4s have turned into 6. Therefore, that line there is 6, and then I'm just going to go ahead and meet the end right there with my 2 vertical lines, or 2 actually diagonal lines. Okay, and there we go. Not pretty, not exactly beautiful, but functional, and all of the scaling is correct, and I'm satisfied. Okay, should I go back there and just show that to you again? And again, if you just check it over, just make sure you have, again, this was 6 here, that was 6 there as well. Okay, so make sure you've done that correctly. And again, if you did this correctly, that's the most important thing. The drawings will come with experience. Okay, so now for something, as we say, a little bit different. We are going to create scale drawings where the horizontal and vertical scale factors are different. Okay, horizontal and vertical scale factors are different. I'll tell you honestly, I know when this happens, when I am messing with something, an image that I'm putting into a PowerPoint or something like that, and I can't quite fit it, so I will squeeze it in, and my scale factors will be off. Maybe I've stretched it, so my horizontal factor is going to be, over 100%, and my vertical will be, 100% or less. But I don't know exactly why you do this. But well, let's just read here. Maybe they'll explain it to us. So here it says, sometimes it is helpful to make a scale drawing where the horizontal and vertical scale factors are different, such as creating diagrams in the field of engineering. Okay, so if you have any engineering dads or moms, and I know at least one of you does in our class, please ask them when this is necessary. I'd really love to hear it from them. But anyway, let's move on. Enough questioning. Having differing scale factors may distort some drawings. See, and this is why I think it's not usually a good idea to do this, but because it can indeed create some distortions. For example, when you are working with a very large horizontal scale, you sometimes must exaggerate the vertical scale in order to make it readable. Okay, I'm not quite sure what that means. Anyway, this can be accomplished by creating a drawing with 2 scales, and that's the point here, and that's what we are about to do. Okay, we're going to create drawings with 2 scales. Okay, unlike the scale drawings with just 1 scale factor, these types of scale drawings may look distorted. Okay, we just mentioned that. Next to the drawing below is a scale drawing with a horizontal scale factor of 50%. Okay, so here's our original drawing here, and here's our horizontal scale factor of 50%. Okay, and then a vertical scale factor of 25%. Okay, and here's our 25%. So what we've done here, it says it's given in 2 steps. So what's happened, we've gone from our original drawing, and we've scaled the horizontal down by 50%, and as you can see, the vertical remains the same. Okay, it's the same height in both this drawing and this drawing. Okay, but you can see that the horizontal scale factor of 50% has been applied. Okay, now going from here to here, we've taken this becomes our new normal. Okay, our new original, and a vertical scale factor of 25% has now been applied. You can see the width on this one and this one remain the same because the horizontal factor has not been touched from here to here. But now we're talking about the vertical factor has been adjusted, and it's down to 25% of this new original, which is this one here. Okay, so I'm going to get rid of all that stuff. Just wanted to explain that to you. What they want you to do right now, and I guess it's kind of what I just did, but I want to do this for you, is just to explain, or with you, to explain how each drawing is created. Okay, explain how each drawing is created. So let's go ahead and go over that. All right. Okay, I'm not sure where all that's coming from. All right, here we go. So from there to there, okay, from the original drawing to the first scale drawing, what happened? Well, the original drawing had a horizontal width of 8, okay, 8 units. All right, so if we applied that 50% scale factor, the way we would go ahead and calculate our new width would be, of course, 8, the original width, times the scale factor, which is 0.5, which is the same as 50%. And therefore, we would come up with 4 as being the new width the scale drawing. Okay, and you can see that's right, and that's what happened right there. You can see what they did. Pretty obvious. Okay, so nothing changed vertically. Okay, those were the same. You can even see the peak on the house. The roof has remained the same height, but looks very different. It's much very interesting here in terms of algebra. Here we're looking at, we have a much steeper slope now, as you can see. It moves the same length vertically in a much faster drop. Okay, only takes a couple of, you can see right here, it only takes a few units for it to go down 4. Here it took 4 units for it to go down that same 4. Okay, all right, and again, that's slope, and that's something you'll see in the near future. Probably not this year, but someday soon. Anyway, that's that. Now, from here, from our scale drawing, the middle scale drawing there, to the final scale drawing, we are going to apply a scale factor, vertical scale factor, very important that this is a vertical scale factor of 25%. How do we do that? I bet you guys know. Okay, what we do now is we're going to take a vertical measurement, and that vertical measurement is 8. Okay, so we have 8 high. It's 8 high. We're going to apply a scale factor now of 25%, which is 0.25, because that's what's been asked for. And we get 2, okay? And we get a height of 2. So now our new height, okay, is 2 units high, and 4 times 0.25, which now we're talking about the our roof, the height of our roof, okay, was 4 over here, okay? And now if we apply 0.25 to that scale factor, we end up with a roof that is only 1 unit high, okay? And therefore our roof has flattened out, okay, as has our entire house flattened out. So by applying 2 different scale factors to this drawing here, okay, we end up with this drawing here, okay? First applied a horizontal scale factor of 50%, and we made it skinny. Okay, we made a skinny house, okay, same height, very skinny, very steep. And then we applied a 25% vertical scale factor, and we made it a bit more squat, okay? But as you can see, it's not the same ratio even at the end as it was at the beginning, and you can just see that, okay? You can just see it because this one is a bit more steeper, a bit steeper than this one, which is more squat. And that would make sense because the way we changed it, we changed its horizontal. The horizontal became a 50% scale, and then vertically it was 25%. Okay, so if these two are not the same, then your final is not going to have the same overall ratio as your original. Okay, it just makes sense. Okay. All right, here comes another little one you can do on your own. May take a little hump to get through, but I'm really, really curious to see how you work your way through that that little hump at the beginning here. And what I mean by that is that it, well, what I mean is that this may throw you for a loop at first. But let's just go ahead and read this here. Create a scale drawing of the following drawing, okay, this diamond here, using a horizontal scale factor of 183 1/3% and a vertical scale factor of 25%, okay? All right, I want you to ponder that. Think about what you can do and how you could approach this. I would just tell you, and I will tell you when you get back, that I would recommend changing this 183 and 1/3% to a fraction. Let's see what you can do with that. Okay, give it a try, and again, if it gets too difficult, come back sooner than later. I'm going to pause now. Okay, we're back. Let's see what you guys and girls were able to do with that. Okay, ugly, and a repeating decimal. Okay, so you can see right away that 183 and 1/3% is really, really ugly. Okay, because anytime you have 1/3%, that's going to be a repeating decimal. It's going to be 0.333333, that 1/3. Okay, get rid of it. Okay, get rid of it right away. So the way I got rid of it, I'll just show you how I went ahead and figured this out. I went and changed it to a fraction, and it might not seem that easy immediately, but hopefully we remember these things, and these things were called complex fractions. Boy, I sure didn't want to go through that so quickly. Let's do that all over again. Okay, so I went ahead first and put 183 and 1/3 over 100. Okay, and again, this is what we've come to know as a complex fraction. Okay, and the reason, and again, this is back from I think the first module as well. Okay, complex fraction. Complex fraction is when you have a fraction over a number or a fraction over a fraction. Which is something we weren't used to, but hopefully you guys do remember that. So I went ahead and started there. And of course, what we've come to learn, okay, hopefully, and continue to learn, is that a fraction, of course, is the numerator divided by the denominator. Okay, so if we go ahead and just do that, I'm going to try to pause. Oh, stop. Okay, so firstly, what I did is I went ahead and took this top, my numerator here, which was a mixed number, 183 and 1/3, and changed it to an improper fraction, okay, which is going to become a lot easier to manage. All right, so I have 550 over 3 over 100. Okay, and again, this is something we have done in the past. I know it's been a long time, but it warrants a little extra practice with now. Okay, and then from there, of course, the way this looks is this. If I'm going to take 550 over 3 and divide it by 100, that means, of course, I am going to multiply it by its reciprocal. Okay, so I have 550 over 3 times 1 over 100. Okay, and this is something, again, I'm hoping that you can learn to apply more and more. We've been doing it a lot, and we've been doing our algebra. Okay, I know it's hard to believe. Hey, when have I been doing that? I didn't realize I was doing that. Yeah, sometimes we don't realize what we're doing when we're doing it, but you guys have been doing this a lot. Every time you've been multiplying by a reciprocal or remember, multiplicative inverse, that's exactly what we've done here, which is nice and neat. I mean, to go from here, which is really weird looking, to this, I mean, how wonderful is that? Okay, and it just shows you that fractions are not just foreign bodies or aliens of any sort. Okay, they're just numbers. Okay, and the goal is, and the trick is to get them to be as friendly as possible. Okay, and right here they are very, very friendly. Okay, so let's move on there. This is real easy. 550, I just multiply across. 550 times 1 is 550. 3 times 100 is 300. And that reduces down to, in my simplest form, as 11/6, which is significantly more friendly than our original 183 and 1/3%. Okay, these are equivalent. Okay, this and this are the same, have the same value. Okay, it's just that we want to be able to be as efficient and as accurate as we can be. Okay, and a percentage such as this does not lend itself to that. Okay, this fraction will do us much, much more nicely. Okay, all right, so let's let's move on. I may have made a mess and gotten in the way of some things, but okay. So what I've done here is I've gone ahead and measured my my vertical width. Horizontal width here of my diamond, and it is 6. Okay, so I need to apply now because my horizontal scale factor is now 11 over 6, and we're going to use this one down here, okay, which is the same as the 183 1/3. But we're going to use that. And if I go ahead and apply it, it's the same exact way. All right, I'm going to go ahead and multiply 6, which is our original, and multiply it by 11 over 6, which is our scale factor. And I get, isn't this nice? Nice and handy. It doesn't always work out this wonderfully, but to get a nice even number like 11 is a very friendly thing, okay? All right. So now I'm going to go ahead and, yeah, that's my horizontal scale factor, right. Now I'm going to go ahead and look at my, my vertical scale factor, which is 25%, which is a lot nicer, okay? 25%, one that we know and love so well. Okay, and my original vertical height of this diamond is 4 units. How easy is this? Apply my 4, use my 4, my original, times my my vertical scale factor of 0.25, and I get 1. Very, very handy. Okay, so now I'm looking at a diamond that's going to be 11 units high in the middle, and 1 unit high in the middle and 11 units stretched out, okay? And believe me, it is very stretched out. And again, once again, the challenge, the biggest challenge is not necessarily in the calculations here, but more so in the drawing, okay? So let's watch me struggle with this drawing. Okay, so that's the easy part. 11 units across, okay, is my my diamond's length. Now the problem with it though is that it's only 1 unit high. Therefore I need to fit this whole diamond across in this one space here, okay? And that's what I had a little bit of difficulty doing when I first did this. And just watch what I do here, okay? And that's the way I decided to do it. I just used the one line up top, drew my little line below it, and you see how this diamond has to fit in just that 1 unit high, okay? And you may do it a different way or have done it a different way. But yeah, there it is, and not very pretty. And again, you can see what happens when you apply 2 different scale factors, you know, one for horizontal and a different one vertically. You can see you get this this distortion, okay? Your image is always going to be distorted when you're using different scale factors that way. And tip, use a ruler. Oh yeah, that's another thing, that's right. Using a ruler to draw these lines might be nice. As you can see, mine is pretty darn messy. Okay, here we go. Here's another one. Chris is building a rectangular pen for his dog. Okay, the dimensions are 12 units long and 5 units wide. And you can see the little picture of it there. Now Chris is going ahead and he's going to build a second pen that is 60% the length of the original and 125% the width of the original. Okay, now this is not going to ask us to draw a picture, but rather I would like you to draw, oops, sorry, didn't mean to do that. Would like you to write equations. Okay, so we're going to go ahead now and we're going to write equations to determine the length and the width of the second pen. And of course we've been doing a lot of that. Now all I want you to do right now with this one is to write those equations. So I'm going to go ahead again and pause, you pause, and let's have you give this a try. Again, you're going to write equations to determine length and width of the second pen using the scale factors that they have supplied us with. Okay, so go ahead, good luck, and come on back to check in. Okay, let's see what you did with this. Okay, so 60% horizontal, 125% vertical. Okay. Now, in terms of horizontal, we have 12 units in our original and 12 times 12 times the scale factor of 0.60, which is 60%, equals 7.2 units, okay? And that is the equation for that, okay? Length of the second pen is 7.2 units, all right? So let's go ahead and look at it vertical, look at the, well, it's not the height, but yeah, the width, I guess. I don't know, it's a width or what? Length and width, yeah, this is the width, the vertical part is the width in a sense. Okay, and we have 5 times 1.25, and again, that's taking our original and multiplying it by the scale factor of 125%, and that equals 6.25 units. Therefore, the width of the second pen is 6.25 units. Okay, and that's it. No picture to draw, just that. Now we have a new one, 7.2 units by 6.5, and again, you can see that chances are we did our job correctly, because vertically, our vertical number should have been larger than the original, which it was, because it was 5 units originally. Now it's 6.25 units. Our horizontal measurement on our new one should have been less than the original, which it is. Originally it was 12 units, and now we're looking at 7.2 units. And again, our scale factor used was less than, excuse me, 100%. Okay. Alrighty, here we go. We are at 51 minutes. Not terrible. We're here at our lesson summary. Let's go through that. Okay, the scale factor, again, is the number that determines whether the new drawing is an enlargement or a reduction of the original. Okay. If the scale factor is greater than 100%, then the resulting drawing will be an enlargement of the original drawing. If the scale factor is less than 100%, then the resulting drawing will be a reduction of the original drawing. Okay, and it pretty much makes sense. Something we shouldn't have too much difficulty. These are words that we've used over and over again in our lives, so we probably won't trip up on that concept too much. Okay. So now when a scale factor is mentioned, so I had mentioned this before, assume that it refers to both vertical and horizontal factors. Okay, so if we say we're going to apply a 50% scale factor to this drawing, you're going to assume they mean both horizontally and vertically. Don't need to even question that. But if it will be noted if the horizontal and vertical factors are intended to be different, okay, which is, again, in our studies here through this module, we'll probably see this again, but I don't suspect you'll see it much in real life. Okay, so to create a scale drawing with both the same vertical and horizontal factors, determine the horizontal and vertical distances of the original drawing. Okay, and that's really important. You can't apply a scale factor to a number, to something whose measurements you don't know. So that's the first step. And again, it's a pretty straightforward step. Something I'm sure you guys understand already. Just do your measurements. Okay. So then you're going to go ahead and use the given scale factor and determine the new corresponding lengths in the scale drawing by writing a numerical equation that requires the scale factor to be multiplied by the original length. And again, like I had mentioned, if you use that Q equals P times W formula, you'll never go wrong. Of course, the Q being the new scale drawing, okay, new scale drawing measurement, and P, of course, that is the scale factor, okay, as a percent, okay, as a percent. And then the W is the original drawing. Okay? Drawing measurement. Okay. And yeah. So you're going to draw the new segments based on the calculations from the original segments, and if the scale factors are different, determine the new corresponding lengths the same way, but use the unique given scale factor for each the horizontal length and vertical length. Okay? And again, that is something we will do again and again, and with practice we will all become perfect at it. Okay, 55 minutes, plenty of time for you, yeah, to finish your problem sets and your exit ticket, and good luck on this, and I hope you learn to enjoy it all. Okay.